Welcome to All Things Data Science, the one-stop channel to help anyone interested in learning or transitioning to data science, just like I did. Specifically today, we're going over another example within the LeetCode series. It'll be the merge to sorted lists. It's in the easy category, but this will be the first video we have about linked lists. Let's dig into it. So here's the problem set. It's fairly self-explanatory. You'll see that here I'm using actually a different input just so we don't get confused with the sort of similar numbers, and I'll walk us through it. The idea, as the title basically alludes to, is you're given two linked lists, and they are sorted, so you don't have to worry about that. And they're in, let's say, an increasing order, and the ultimate thing that we want is basically kind of find a way to mingle them together as you're passing through so that you end up with a completely fully sorted list that is composed of both. So fairly self-explanatory, and they do give you a couple of edge cases to be wary about. Now, one assumption that I personally made is I don't think we can assume that the input linked lists can be of the same size. They don't tell us much, but that's the kind of stuff you should be asking yourself. Here they do tell you that they're in sort of this range in terms of how many nodes the linked list will have, but it could still mean, you know, one is 50 and the other is just one node input list. Okay. And here we are. I'll walk us through briefly this and then maybe visually also draw the linked lists, and hopefully that'll explain it better. So the idea is specifically having these two sets of linked lists, and just as a reminder, the problem set shows us how they define the class. So that's what we're doing here. You don't have to exactly type it this way. You should be able to just, for example, drop this part because that's already the default anyways, and other aspects to it. For extra explicitly, that's what I'm using here. Now, what's most important is, of course, first checking if the linked lists are not empty, i.e., for example, this use case or one of the other ones is, so if any of these happens, then that'll basically skip this part and go straight over here. And you double check, okay, which one of the two is empty? All right, it's L1, so it's going to be this case, and basically you sort of end up directly with the one that wasn't empty, which in this case only has a 0. It could have had a 1 and 2 and other things, but you get the point. You'll just return the one that had the elements and wasn't a none. Okay, and the other bit now is obviously when it's more interesting and it has things in it, then because we're looking at an ascending order from 1 to sort of a higher instance in this particular case, then what we mean there is, well, if you have a lower value as one of these nodes that I'm traversing across, then that's the one I want to grab. And that's the one I want my this little variable that I'm calling a temporary linked list to have as its next piece. There's going to be like a couple of interesting things with the none, and just how in the world at the very end we just pass in this thing and it has a solution. So once we do the visual part, that'll be super clear. And then otherwise, of course, if it was, you know, the next node being the L2 that's actually smaller, then that's where you're going to grab. But you also make sure, you know, in this case, it doesn't matter 1, 1, but in our case here, if L1 was 1, 2, 3, or 1, 3, 5, and the other one is 2, 4, 6, then you want to make sure after you're done assigning the L1 to your next, then you make the L1 only 3, 5. And you sort of move on, and it'll be the same once you give the 2, it'll just keep that last bit. And that's pretty much it. So that'll take care of going all the way to when one of them becomes empty. And then we already explained when you reach that point, then you just want to throw in there any remaining nodes. So let's do a quick visualization, and I think then we can wrap it up. It's not too bad, but at least it's a good sort of easy one to start with for linked list explanations. All right, so what's going on here? So instead of these, I'm going to be using 135 as the input and as sort of L1, and then L2 is going to be 246. So what's happening over here is, and I'm actually going to use black this time. Over here, we're starting out with our sort of initialized linked lists that are going to be useful for the return part. So here you could think of it as, yeah, like both of them, this sorted and the temp, they're basically pointing to like an empty linked list, and then we enter this part, right? So what happens over here? Here we look in here and we say, all right, 1 or 2, which one is bigger? Turns out that 2 is, so therefore we stick to this particular one, which comes from L1, and therefore for temp LL specifically, we keep the null, and to it we give the next pointer, we give it what L1 is, because we're giving it all of N1, right? And we could always think of a linked list as really similar to what they have in the visualization. These are really actually little blocks that are connected to one another and should always be thought of as that way. So when we tell it to give us L1, you're really kind of getting the whole of L1. So what does that mean? You're getting this, this, and this. And now you move on, right? You're done. You're not going to look at the else. You get to this particular point. What that one is saying is, you know, I was over here. Now basically I'm going to be over here. And so next time we say dot next, it's sort of referring to this section, right? So let's see what that means. So we come through the second time. So this was, you know, part 1. Now round 2. What's happening? This time around, what are we left with? We're left with an L1 that only has 3, 5. And the L2 has 2. So now we're really comparing 3 and 2. 2 happens to be the smaller one, so that's the one we're going to get. And so this time, what do we got? We sort of have this thing where we have a temp, we have a 1 that's pointing here, and we're telling it, please, for the next, this is what's happening over here. We're telling it for my next, give it all of L2. So this is what's happening. Okay, and then we move to round 3. So now the L2 was told to also kind of move on and just use the next part onwards. Realistically, really, I mean, I'm drawing them this way, where I'm completely removing the thing, but you could sort of think about it as, you know, the 2 still exist. You're sort of moving the pointer to be the part next. So think of it that way, and those other parts sort of still exist, but your pointer is not looking at that point stage in time. All right, and so we move to part 3, and then we're going to be over here. We're comparing 3 and 4. We're going to get it. And I explicitly chose that example so that they're intertwined. And basically, we have this. We've already told earlier our, over here, we've already told our temp to move to the next thing. So its pointer is over here for this particular section. And it's got the 1, it's got the 2, and then it's telling us, all right, so for the one that I'm calling next, so here this time we're in the L1, what am I left with? I'm left with this, and basically we keep on going until at the very end we end up, actually we're not that far, but basically at the end, very end, we have a couple of things. We're over here, i.e. done with the while loop. Realistically, what has happened, right? We kind of continued with moving this pointer over here, and basically, if I'm putting that little arrow thing, it's over here, and then we suddenly also moved this pointer over here when we were comparing. And so the very last item that we're adding at the while loop level is going to be temp LL being this, and the 1, and the 2, and the 3, and the 4. Actually, let me do it this way, that way it still looks good. 4 and 5. So we're going to stop at there, because then what's happening is at the level of 5, once we reach this part, then we enter the while loop, and then we're now in the case where actually L1 is none. So what do? We're over here. It's not the first if statement, it's over here. So basically now we're telling for the next part over here, I'm going to grab whatever is left of my L2, which we know is going to be only 6. And so that gets added over here. And then one thing we forgot about all the way back, but not really, is we also called something sorted DLL, so sorted linked list, and that was equal to a temp LL. So this temp LL has been doing all of this stuff over here, and at the very end actually did end up with something pretty sorted. And the fun part is this whole time the sorted LL was still pointing at the beginning. So the only thing you have to do at the end is say, all right, I've got my sorted thing, just give me the next. And we're skipping the next because, you know, we don't need this non at the beginning. And so that leaves us with just this part, which is exactly what we need to return. So hopefully that was helpful and clear enough. Please, as usual, feel free to ask any questions in the comment section or elsewhere. And if you like it, please subscribe. Looking forward to your feedback. Bye-bye.